Hello, my name is Doug Rumbaugh, and welcome to the first video in my series on understanding C pointers. Pointers are one of those aspects of the C programming language that are fairly important to being able to use the language in a meaningful manner, but tend to present a lot of difficulty for people who are unfamiliar with them. It's not necessarily that pointers are complicated, it's just that they're a little bit difficult to come to grips with and get used to using. So I'm hoping through this series of videos that I can introduce you at least to some of the basic ideas and get you moving towards having an understanding of these things. Now, part of the reason why pointers are so tricky is because it requires understanding a little bit about computer memory. We're not going to start by diving right into memory models or anything like that, but I do need to talk a little bit about where stuff gets put in memory, or more specifically, how variables are stored in memory, in order for a discussion of pointers to have any semblance of understandability whatsoever. That's where we're going to start here. Now, the way I'm going to do that is by comparing and contrasting the way that C handles variables to the way that Python handles variables. And realistically, you can substitute Python for whatever dynamically typed programming language you like. They mostly work in this same fashion as far as I'm aware. So things like JavaScript or Lua. Java works this way when you're not dealing with primitive types. C# works this way when you're looking at classes, types that are defined by classes, things like that. So to begin with, I want to begin with a very idealized view of memory using a representation called an idealized memory diagram. This is not going to give us a whole lot of information about where things are laid out and all that sort of thing, and it doesn't need to. The point is just to get some way of representing what the hell is going on, and then we'll extend it slightly when we get to talking about C, because we have to because of the way that C works. Now, the way that a basic idealized memory diagram works is we're going to consider memory to be an array. So we have a bunch of these boxes into which we're going to stick things, and these boxes have numbers that are associated with them, the index or the memory address. Now, let's consider the Python statement x equals 5 and see how Python executes this statement. The way that this works in Python is when you have an assignment statement, what it is you have a variable name, you'll have the assignment operator, although it's not really an operator. That's sort of a semantic argument, but it's called the assignment operator. In Python, it's not actually an operator. It functions more like a keyword. In any case, you have a variable name, you have an operator, the assignment operator, the single equals sign, and then you have some expression. The way that Python works is when it sees an expression, it's going to evaluate that expression to create an object. So in the case of 5, this is a literal, an integer literal. So Python is going to evaluate this integer literal 5, creating an object representing the number 5 somewhere in memory. Doesn't really matter where. I'm going to stick it here in box 4. And I'm going to put a little O in parentheses under here to indicate that what we're looking at is an object. This is the data that actually represents 5. Now, a variable in Python is a label that is applied to a box. However, confusingly, it is not applied to box 4, the one which contains our data. I'm going to stick it over here in 0, although again, it doesn't really matter for our purposes where we put it, as long as it's not that 4. So once we have the object created and in memory somewhere, and we have our variable created and in memory somewhere, the actual assignment operation creates a link between them, and that link looks like this. So the variable x is a box which contains the number 4, which is actually the memory address of the data that has been associated with x. This is what's called a reference variable. So reference is the key word here. because a variable is containing a reference. It doesn't actually contain data. It contains instructions on how to get to the data. Now, this is very significant for dynamically typed languages because if we wanted to peel back a little bit of this abstraction, the box into which we are putting something needs to be sized appropriately to hold that something. And Python will just as easily allow you to say x equals 5 as it will allow you to say x equals an array containing 1,000,000 elements. And as I'm sure you can imagine, an array of 1,000,000 elements and 5 are not the same size. But Python will happily allow you to assign 5 to x, and then in the very next statement assign this array. The reason why this works is because what Python will do is it will just stick that array somewhere else in memory, and then it will update the variable to contain a reference to that new array. So the variable only ever contains a reference, which is of a fixed size. So all Python variables are the same size, and this is actually where that statement you'll probably hear comes from, that Python variables do not have an associated data type, because all the variable is a memory address. The data type is actually on the object that's stored out here in the heap. Now, I shouldn't say that. When we get to memory management, the memory model, we'll talk about stacks and heaps and whatnot. Some Python people get snippy when you call it the heap because that's an implementation detail that's not specified in the language specification. But whatever, the object data is stored somewhere else is the operative bit there. Doesn't much matter what you call it. Now, C works a little bit differently from this. And this is part of the reason why C needs pointers, and also some of where pointer utility comes from. Because if we're looking at the same thing in C, now of course in C, we have to define a data type. It's not enough to say x equals 5. I have to say int x equals 5. That data type is very important for a reason we're about to see. And no pun intended. So we'll go ahead and create our little array here. Just the same. Should point out that, again, an assignment statement in C, this equal sign is actually an operator. You can use an assignment in C as an expression inside of program control and things like that, which you'll see quite often. In Python, it is not an operator. You cannot use this as anything other than an independent statement. But that's not the difference we want to talk about today. The difference is this. Again, a variable is just a label on one of these boxes. However, C just sticks the 5 inside the box. This is a value type. So, in both cases, a variable is a name for a region of memory, what we're calling a box here. In Python, a variable gets a reference to another region of memory where the data is actually stored, which is what allows us to stick things of different data types under the same variable, one after the other. In C, however, the data gets put in the labeled box. So the name x refers to the chunk of memory containing the zeros and ones that represent the number 5. Because of this, in C, your different variables are going to be different sizes. It's not just storing a reference, it's actually storing the data. The size of a C variable is specified by the data type. And in fact, that's one of the primary purposes of a data type in C, is to specify how big of a box we want to set aside. And C provides you with an operator or a function. I believe it's technically an operator, but it looks like a function when you call it, that you can use to figure out how big these different data types are. And that's what's called size of. So, as a quick example, let's hop over into some C code here, and we'll do this. I'm going to say int x equals 5. And let's go ahead and grab the size of an integer. Just like that. C is, of course, a compiled language, so we're going to go ahead and compile our thing and then run it. And what we get is we get 4. Now in C, the size of a data type is specified in bytes. So an integer is 4 bytes. That is 32 bits. So it's a 32-bit integer, which probably sounds somewhat familiar. We also have character, char, which is just 1 byte. That represents your smallest thing. Now, technically, the sizes of these data types are computer dependent. So different processor architectures and whatnot, and different compilers even, can result in different sizes of the variables. So you don't want to be hard coding any of these numbers anywhere. You want to use size of to make sure everything works dynamically. But the point is, data type specifies size. So if we wanted to take our idealized memory diagram and make it a little bit more real, not quite as ideal, what we could do instead is we could consider each of these 0, 1, 2, 3 whatevers to represent a byte of memory, in which case our x, our integer x, is actually going to span, we'll leave those barriers in place, is actually going to span 4 boxes. So that's x. And of course it contains a 5. Whereas if we had a character, say we had C is equal to A, assign C to A like that. C, a character data type, takes up a single box because character is of size 1. At least on my computer it is. And this is going to be important to understand when we start talking about pointers then. So just to recap, in this video we've talked about how variables are represented in C and in Python and the differences between them. In Python, every variable contains a reference to an object that is stored somewhere else in memory. So all variables are of the same size, and variables do not possess data type. It is simply a memory address, or you can think of it as an array index that tells Python where to look to actually get the data that you're looking at. This is what allows you to dynamically assign different data type objects to the same variable, as we see here with 5 and then an array of 1,000,000 elements. C, by contrast, actually stores the data directly inside of the variable. So x equals 5. X is going to refer to a chunk of memory which actually contains the number 5. What this means is that your C variables are going to be of different sizes. As you can see here, x takes up 4 boxes because it's an integer, whereas C is only going to take up 1 box because it is a character. The data type specifies how big of a box you want to look at. And you can actually have a lot of fun with, say, numeric types like long, int, and char. Char is actually a numeric type. Just casting or treating various integers as characters or characters as integers and just seeing what happens, because you can do all kinds of fun stuff with that. And C will let you do it because it's weakly typed. You may get some warnings, but whatever. Something to have fun with. In any case, that is the critical distinction, is that C stores values directly in variables. Python stores references in variables. And so what we will see in the next episode of this is that this whole pointer concept in C comes into play because often we actually want references. We don't want values. We want to be able to refer to things by location, pass the locations of things around. And so that's what pointers allow us to do. Is a pointer, just to perhaps jump ahead and spoil a little bit, a pointer is going to allow us to specify a variable by location. So if x refers to the number 5, so x is actually the integer 5, the address of x, ampersand x, which is a pointer, is going to be 0, the box. And that's what we're going to talk about in the next part of this series. I hope that this was helpful and that you found this interesting, and I'll see you in the next video, whichever one that happens to be.